We all know large language models are incredible. They're amazing generalists, right? But what happens when you need an expert? In this explainer, we're going to walk through the architect's blueprint for turning a powerful, general AI into a true specialist that knows your specific data inside and out.
So here's our game plan. First, we'll nail down the core problem, then we'll look at the standard solution for it. After that, we're going to dig into two really critical areas, getting your data ready and then pulling it out intelligently. And finally, we'll see how the whole shebang comes together in a real working application.
Okay, so what is the actual problem we're trying to solve here? Well, models like GPT-4 are trained on this gigantic snapshot of the public internet. So yeah, they know about history, they know about science, pop culture, you name it. But they have absolutely no idea about your company's internal reports, your latest sales figures, or what just happened in the news 5 minutes ago. And that, right there, is the knowledge gap.
And that leads to the big question for any architect or developer. The answer, by the way, is not to retrain the whole model. I mean, that would be unbelievably expensive and slow. No, the real secret is to give the AI access to a kind of specialized external library that it can check out in real time.
And the industry standard way to do this, the architecture for solving this whole problem, is called Retrieval Augmented Generation, or as everyone calls it, RAG. This is the foundational pattern that we're going to build everything on. You know, at its heart, RAG is a pretty simple idea. Instead of just firing a question at the AI, you first do a quick search through your private data to find anything that seems relevant. Then you hand the AI both your original question and the relevant info you just found, and you basically say, okay, now answer my question using this context. And this whole process really breaks down into 5 straightforward steps. It all starts when a user asks a question. That's the query. Then, the system searches a special kind of database, one that's built to find things based on meaning, not just keywords. It then retrieves the best pieces of information. It augments the original question by tacking on that retrieved info. And only then, with all that context, does the LLM generate the final answer. It's simple, it's elegant, and it is seriously powerful.
But, and this is a big but, here's the catch. The quality of that final answer you get depends almost entirely on the quality of the information you retrieve. And that depends on how you prepared your data to begin with. Which brings us to what I like to call the critical art of chunking.
I mean, just look at this. The difference is night and day, right? If you just randomly chop up your documents, you get these meaningless little fragments like you see on the left. The word mountains is literally broken in half. No AI on Earth can make sense of that. But good chunking, over on the right, it keeps the complete thoughts together, creating these high-quality, meaningful pieces of information that the AI can actually search through.
A good way to think about this is like a ladder of sophistication. Down at the bottom, you've got the really basic methods, like just splitting the text every 1,000 characters. But as you climb up that ladder, the methods get a lot smarter. They start to understand the document structure. And eventually, they even use AI itself to create the perfect chunks.
And right at the top of that ladder are the really advanced strategies. Semantic chunking, for instance, uses what are called embeddings, basically a numerical version of a sentence's meaning to find the natural breaking points between ideas. And then there's agentic chunking, which is kind of the holy grail. It uses an LLM to actually rewrite each chunk so it can be fully understood all on its own. And this is so important because it creates this perfect library of self-contained facts, which just maximizes your chances of finding exactly what you need.
Okay, so having perfectly formed chunks is half the battle. But look, if your system can't find the right one when you have millions of them, all that quality is just wasted. This is where advanced retrieval strategies come into play, making sure your search process is just as smart as your data prep. Just think of these as different tools in your toolkit. Re-ranking, for example. It's like getting a second opinion from a specialist model that resorts an initial search to find the absolute best hits. Query expansion uses an LLM to turn a kind of vague question from a user into several really detailed ones to search for. And hierarchical RAG is brilliant. It solves this problem of precision versus context. It searches for a specific sentence, but then it pulls back the entire page that sentence came from. And here's the key takeaway. You don't just pick one of these. As AI expert Cole Meden points out, the best, most robust systems are built by layering these strategies together. And why is that? Well, because each one acts as a kind of safety net for the others. The query expansion finds more potential answers, and then the re-ranker filters that bigger set for quality. You end up with this really resilient system that delivers the best possible context to the AI every single time. Okay, so we've got our data perfectly prepared, and we have our retrieval strategy totally optimized. But how does this RAG pipeline actually plug into a real application? Well, the answer is something called the Agent Tool Framework.
See, an AI agent isn't just an LLM. As we've seen from some great builds, like one from Tech with Tim, it has three core parts. It has the LLM, which acts as its brain. It has a system prompt, which is basically its instruction manual and its personality. And, most importantly, it has a set of tools that it can decide to use.
So what is a tool, anyway? It's really just a function, in this case, a Python function, that the agent can call to do a specific job. That whole sophisticated RAG pipeline we just designed, with all its fancy chunking and re-ranking, it all gets bundled up into a single tool, something the agent can call on, maybe named search_internal documents.
And this is the final piece of the puzzle. The agent is like the conductor of an orchestra. When a user asks something like, "Hey, what were the key takeaways from last quarter's sales report?" the agent's brain realizes, whoa, I can't answer that from my general knowledge. So it decides to use its Search Internal Documents tool. It runs our entire RAG pipeline, gets the relevant context back, and then it puts together the final answer.
And just like that, the transformation is complete. You haven't just answered a single question. You've actually architected a system that turns a generalist AI into a true specialist. You've given it an external, reliable memory that it can intelligently dip into whenever it needs to.
So, there you have it. This is the blueprint for building AI systems that have deep, specific knowledge about a certain domain. The only question left is, what expert knowledge are you going to build first?